So last time I had asked you to learn a little bit about Eratosthenes as well as answer some questions about him. So I want to kind of go over some of those this time before we get into your next assignment. So I am not going to take these questions in order because I think a few of them require some explanation before we do questions 1, 2, and 3. So number 4, about knowing 3 to 5 facts about his life. And that should have just come from your reading. I'm not going to go over those because I'm fairly certain all of you should have been able to read those couple of paragraphs and pull those out. But number 5, can you thoroughly explain how Eratosthenes determined the size of the Earth, including words, a sketch, and a math formula? So I did not include here a sketch because there's one in your book, there was one in the video, but I wanted to go over the main key points here. So it was important that this measurement was done on the summer solstice at noon because that allowed the sun to be directly overhead. And in Alexandria, there was a shadow cast by the stick in the ground, and that was at an angle of 7.2 degrees. And in Syene, there was no shadow cast because truly the sun was overhead directly. The distance between Alexandria and Syene was 5,000 stadia, and we're working in stadia just because it makes this number of 5,000 to be very easy and a very nice round number. So then I would say draw a picture to help you set it all up, and you've got a number of examples for that, and I'm not going to try to do that here in PowerPoint. So your proportion that you set up is the angle in Alexandria compared to the total number of degrees in a circle. So you get 7.2 degrees over 360 degrees. And that proportion is going to be equal to the distance between the two cities and the total distance around the entire Earth. So you've got 5,000 stadia over x. And so if you solve for x, you're going to find that this ends up being 250,000 stadia, which is very close to today's actual accepted value. It's 1.4% off, which is remarkably close for a very simple mathematical proportion. There's nothing fancy about this formula, and that is part of why he is considered to be, this is considered to be a very important science experiment because it took some fairly simple knowledge and the shadow of a sun, which we see all the time, and very basic math to come up with the size of the Earth. So let's go over some of the other questions. Number 1, when the sun was directly overhead in Syene, why wasn't it directly overhead in Alexandria? That's because Alexandria was farther north at a higher latitude, which if the sun is directly overhead somewhere farther south, it is not going to be directly overhead farther north, just due to the way the angles are and how the sun and the Earth interact, or the Earth goes around the sun. So number 2, if the Earth were smaller than it is, but the Alexandria to Syene distance were the same, would the shadow of the vertical pillar in Alexandria be longer or shorter at noon during the summer solstice? So the shadow would be longer because on the smaller planet, the angle of the pole would be greater relative to the sunlight. So the ratio of the shadow to the pole height would be greater than 1 to 8 as in the previous answer. And you can prove this to yourself by going into that proportion that we looked at above here, where we had the angle at the city divided by 360 was equal to 5,000 over the total area of the, or total size of the Earth. And in this case, I just made the size of the Earth smaller. It doesn't matter what number you picked. I just thought this would make it an easier round number, and you could kind of see what happens with x. So this should give you a little bit of practice of looking at proportions. I anticipate there's some of you that this is not a easy and obvious thing to do, which is why I wanted to discuss it. Number 3, If the angle found by Eratosthenes was larger, let's say 10 degrees, how would that have affected their calculation of the size of the Earth? Would it be larger or smaller, and why? So if you take that original proportion that we have, so the angle divided by 360 equals 5,000 over x. And in this case, the angle here is going to be 10, they told us, because it's a larger angle. When you solve for x, you're going to get 180,000 stadia, which makes the size of the Earth smaller than it was when it was 7.2 degrees. So again, this is playing with proportions, which is relatively simple math. So I do anticipate that there's a few of you who might be struggling with this, and that's okay. That this is time for you to practice this a little bit more. So if you can confidently answer all of these questions without using your notes, you're ready for the Eratosthenes assessment, and you can take that online and then move on to the next video. But if not, I'm going to suggest that you study the facts about Eratosthenes more. You practice explaining how he measured the size of the Earth to a classmate or a parent or another teacher. Be sure you can draw the pictures. Make up some questions involving the proportions and seeing if you can better understand what happens if any of these scenarios. So the first one to think about is the angle of the stick changes. If it goes up, what happens? If it goes down, what happens? Another thing to consider is the size of the Earth. If it goes up, what does that do? If it goes down, what does that do? What about the distance between the two cities? If it changes, what happens? So look at these and see the effect that these would have on the other pieces of information that's in that proportion, just to make certain that you're comfortable with doing that. So when you are ready, go ahead and take the Eratosthenes assessment, and then you can come on to watch the next video.